घरच्यांनी पळायला सुरू केलं. लोना काढी म्हणून तुम्ही तो लोना काढे नहीं क्योंकि बाप के आस्ते लाले को भेंट कर दे 15,000 500 आता था।
बॉडी बॉडी लेके चलेंगे हम? नहीं
Good evening, everyone. Speaker for this session is today's session is Dr. Mohammad Arifuddin Sohail. Sir has already joined the meeting. We were waiting for the participants to join. We'll start off. It is my absolute honor to introduce our esteemed speaker for this session, Dr. Mohammad Arifuddin Sohail, a distinguished professional in the field of electronics and communication engineering. Dr. Mohammad Arifuddin Sohail is working as Head of Research and Development at Advanced Communication and Electronic Systems, Saudi Arabia for the last 2 years. Prior to this, Dr. Arif was the Professor and Head of Department of Electronics and Communication Engineering at Mufakhamja College of Engineering and Technology, Hyderabad. He did his Bachelor's of Engineering in Electronics and Communication from Mufakhamja College of Engineering and Technology. He then pursued his Master's in Microelectronics Engineering for RMIT Institute in Melbourne, Australia, and PhD in Analog VLSI Design in 2015 from JNTU, Hyderabad. He has 19 years of teaching experience coupled with 2 years of industry exposure. A life member of IETE and an active member of IEEE, he also holds the prestigious role of Secretary for the IEEE New South Wales Section, Australia. With his vast expertise in the field of electronics and communication engineering, Dr. Arif is here to share his knowledge and insights with us today. Now I welcome Dr. Mohammad Arifuddin Sohail sir to take over the session.
Very good evening to all the participants. At the outset, I would like to thank the organizers, Manu, Ms. Hajra Fatima, Dr. Yusuf Khan, and all the other organizers for giving me this opportunity to be able to share some information that I've got with all of you. Pardon me for not sharing my camera. It's 11:30 p.m. in the night here, and I feel it's better that I don't share the camera. Can I get the sharing rights, Hajra, for sharing my presentation, please?
Yes, sir. You can share the presentation.
Okay. I hope you're all able to see my screen.
Yes, sir.
Okay. So before I go ahead with my presentation, I'll just take a few minutes to talk to you about my organization. It's customary that I would like to thank my organization for giving me this opportunity, to represent it and be able to speak before you. The company for which I work is called Advanced Communication Electronic Systems. It has been established 30 years back in Saudi Arabia with 60 plus offices and 4,000 plus employees. We have a current business of 3.5 billion Saudi riyals. and we are predominantly into the telecommunication sector. These are all our clients. All the Saudi government entities are our clients for which we work for. Our company is further divided into four, and I have the privilege of being associated with all the four. I work in all these four domains. Aerial solutions is with respect to drones. So I work with image processing using drone footage for oil and gas, Saudi Aramco. Then ACES India is into neutral hosting, telecommunication. ACES neutral host is into optical fiber communication, and ACES defense is in radars. So with my experience in electronics, I get an opportunity to dabble with various current technologies. These are the various departments, portfolios. Neutral host is one of the biggest business that we have got. We are the licensed operators from CST, and we do internal telecommunication networks for buildings, arenas, indoor and outdoor. We have the technologies of IBS, DAS, small cell, and private networks. This is our footprint. We are present at different places in Saudi Arabia, and in India, we are available at 6 different places. These are our success stories. The Grand Mosque at Mecca and Medina. We have our network at these places, and all the other important places like airports, metros, and financial district, and all the other things. Within India, we are present at Mumbai Metro, the network at Mumbai Metro, Bangalore International Airport, Surat Diamond Bourse, Agra Metro, and the upcoming Noida Airport is also from our side. Riyadh Metro, which has recently been launched, is completely the internet Wi-Fi is provided by ACES. And we work with smart solutions. In fact, the first smart city in Yambu from Saudi Arabia, we were the one who deployed the complete smart city solutions. And I don't want to tell you what smart city solution is all about, but we did everything there. We do integrated security. It's not just the physical security. We talk about the security at the digital level as well. And we have the security at all the important power plants in Saudi Arabia. The latest business that we are into is data centers. So we build, construct, we do the cooling systems, power distribution, redundancy, and we build grain data centers. Currently, I am dabbling with multiple projects which involve migration of on-prem to cloud infrastructure. So we are heavily into data centers. A few examples of the data centers that we are building in Saudi Arabia. And our regular business is managed telecom services. So we cater for STC, Mobile, and Zain. Just like we have Reliance, Airtel, we have got STC, Mobile, and Zain. So this was a brief introduction about my company. It just took a few minutes for that. And I work as the research head for this organization. Now, let me talk to you about, I'll go full screen. Let me talk to you about the energy harvesting for sustainability of low power electronic devices. And I want to actually narrow this down to wearable technology. So basically, these are the topics which I will be covering on. Let's talk about low power wearable devices. Anything that you wear starts from shirt, pants, shoes, socks, watch, glasses, rings, smart finger, GPS, baby control, belt. All of these devices are smart devices. Nowadays, you can get electronics into all these devices. The big issue is, how are we going to charge these devices? How are we going to maintain the battery into them? And that's exactly what I'm trying to discuss in today's presentation. Energy harvesting for all these low power devices. I will also briefly touch upon medical devices. You will come to know the reason why. Medical devices like, which monitor blood pressure, pain management, hearing aid, enuresis, vital signs, remote patient monitoring, all these medical devices are very, very important today. And where are they located? The wearables right from head to toe. On the head, you can have immersive infotainment helmets. In the ears, you have headphones, hearing aids, ear-worn trackers. Eyes, you have got smart eyewear, AR, VR, glasses, smart contact lenses. On the body, you've got smart clothing. patches. On the arms, you've got medical smartwear, arm worn trackers, skin patches again. On the wrist, you've got smartwatches, wrist worn fitness trackers. Legs, you've got smart footwear. As I just said, shoes and socks. And I'm not even touching the implantables, which are inside your body. And all of you know very well about the pacemaker, which is an implantable device. I'm just going to talk about what we wear externally. And why did I discuss the wearables along with medical devices? Because we are going towards a synergy of both of them. You can see that the consumer electronic companies like Samsung, Bose, Apple, Fitbit, these are all into wearable devices. But now these companies are collaborating with health and medical devices like Philips, Medtronic, Omron, Starkey, and together they are building wearable medical devices. All of you are very well aware about the Apple phone, the Apple smartwatch. But when Tim Cook was asked, what do you think would be the single greatest contribution of Apple? He said it will be in the area of healthcare. So Apple in healthcare, that's what is the biggest contribution. And we have got multiple things happening in the healthcare domain. And let's just briefly touch upon the growth of wearables. From 2015 to 2026, you can see that the industry has grown like anything. From 20 billion US dollars, it has grown to $160 billion. And the number of units are around 5 million units. And there is exponential growth as such. Growth of hearables and wearables. So frankly speaking, when I say we have got wearables, probably back in 2018, there were about 180 million units, of which a significant part, around 19%, was 33 million units of hearables. People used to wear a lot of hearable devices in the ears. The market has increased at a compounded annual growth CAGR rate of 20%. And it is now at 453 million units. Not now, like at least a couple of years back. And substantially, there is an increase in the hearables, which is 158 million units, 36% of the market. You can see that each of these devices, smartwatches, clothing, ear-worn, wristbands, sports watches, everyone has increased. And I want to discuss with you in today's presentation what is going to make this more exciting. 453 million devices are there. How are you going to charge them? How will you replace the batteries for these many devices? What is going to happen with the 453 million batteries? They have to work every day, every week, month, and year. How is that going to happen? Please think about it. Every one of you have at least one or two phones. You've got a laptop. You've got probably an iPad or a desktop or whatever. You may have a smartwatch. Men may have trimmers. Everything needs to be charged. And frankly, we are so busy in our day-to-day routines that we forget to charge things. And if you forget to charge our mobile phone, then it's havoc, it's terror. All right. How are we going to end up charging so many devices? Let me talk to you about the battery strain in only one device, which is a clock, a watch. The first one that you see here is a wristwatch, a normal wristwatch. And what is happening? It has only a 7-segment display with numbers. It has some basic watch functions, like you might have a small LED and a small alarm which will make a small sound. And it has a multi-year battery. Once you put a battery, it will go for 3 years, 4 years, whatever. And you go pay 50, 100 rupees and change the battery, and it keeps running. But does that happen with your Apple phone, Apple Watch, or any smartwatch? Do you think any smartwatch can last more than 3 days if you're using it regularly, wearing it on your wrist? Of course not. And you have to charge it. If you're not charging the watch, it is as good as a dud. You just have to throw it off. And what are the functionalities inside these smartwatches? First of all, the display will be very interesting. You have watch functions, of course, you will see time. You also have the motion and activity tracking, heart rate monitoring. You can find out how much is the heart beating with the small heart symbol. You have GPS in these watches. You can find out the altimeter, thermometer, and of course, Bluetooth. I mean, you know that you can take calls from these watches. The watch will ring whenever you get a call on your phone. So the watch is connected to your phone. So basically, the new functions inside the watch, apart from just displaying the numbers of time and date, is it has a cellular radio, it has sensors, and it has analysis and whatnot. So this is what is straining the battery, and the battery is going down every day. And for those of you who are from the background of electronics, and even if you are not, everyone knows that there is something called as Moore's law. What is this Moore's law? Integrated circuits, I mean the chips, the microprocessor chips. Mr. Gordon Moore said that the number of transistors, so these chips are made up of transistors, silicon transistors. The number of transistors in every chip is going to get doubled every 2 years. And you can see that the increase is like, 2 power x, keeps on increasing with respect to the timeline. The same is the capacity of the hard disk. A very high increase in the memory capacity. Very good. So we are increasing processing capability, we are increasing memory, we are increasing hard disk, but are we increasing the battery capacity? 6 years back, whatever was the battery, did we increase it by 20 times or 12 times? No, we did not. In fact, just for sharing purpose, I'm telling you that the number of transistors inside a Cerebras wafer scale engine 2 is 2.6 trillion transistors, which uses 7 nanometer FinFET process. This is a processor. Micron is a company. They have come up with a flash memory, NAND flash memory, and they have got 5.3 trillion floating gate MOSFETs. NVIDIA has come up with a GPU. How many transistors? 104 billion transistors. Just imagine. And that two of them. So totally 208 billion transistors inside the NVIDIA GPU. And of course, Apple. You use the Apple's devices. The Apple M2, 134 million transistors inside it. 5 nanometer technology. So this is increasing like anything. But what about the lithium-ion battery? No, it's not increasing. There is no Moore's law. There is no exponential increase in the battery capacity or whatsoever. You're still stuck up with the same battery, but you are expecting very, very high performance to support trillions of transistors. How is that going to happen? Okay, so let me discuss a little bit about an electronic microcontroller. You all know microprocessor, microcontroller. As I'm an electronics and communication engineering background person, I will talk to you about that flavor a lot. So MAX 32620 is from Maxim Integrated. It is an ARM Cortex M4 microcontroller. So basically, this is the processing part, the heart of the chip. Apart from that, what else have you got? You have got a pulse oximeter, a heart rate sensor inside it, a 3-axis accelerometer, a gyroscope, barometric pressure sensor, a clinical grade temperature sensor. You can even connect this to ECG channels and monitor the ECG of a person. There is a HR heart rate detection algorithm running onto it. Of course, you'll have the flash memory and the Bluetooth and the ultra low power management IC. You can connect it with a USB Type-C, and all of these many things have to be supported by a small coin cell battery. Just imagine. How is this going to happen? Each one of them, how much power is going to be consumed by each of these devices? And how is this battery going to support this much power? And even if it does, will it last for a few hours? And then you will put it on charging again, and then you take it out and use it again, you will put it on charging? No. What is the solution? I'm taking you towards that. Just briefly discussing about the variable power budget. As I just mentioned, the most important component inside any wearable device is the microcontroller unit, radio, sensor, display, and power management IC. The other parts are also there, but let me just talk to you about each one of them. The maximum power that will be consumed will be with the display, about 10 to 100 milliwatts. The processing unit will be 0.1 to 10 milliwatts. Radio, when I say radio, I don't mean radio, I mean communications. How is this chip going to communicate with your mobile phone or your internet, IoT, and all that? 10 to 30 milliwatts. Heart rate monitor, very less power consumption, 0.1 to 1 milliwatt. GPS receiver, 10 to 100 milliwatts. And power management unit, every chip or every small device will have a power management unit, which will itself consume 10 to 20% of the entire system power. So I have put the numbers in front of you, and please bear in mind, you have to ensure that you get this much power from somewhere or the other. What is the source? How are you going to get it? Okay. You'll say, no, let me try and reduce. Okay. How? I'll reduce the power consumed by the CPU. So a slide on that. What we will use is the FinFET architecture. All right. Nowadays, all the chips that are coming, FinFET based. All right. Consume very, very less power. Apart from that, we are also reducing the power. Instead of giving DC power, we are giving pulse width modulated power. Instead of giving 1.2 volts supply voltage, we are reducing it to 0.3 volts supply voltage, which is called as subthreshold circuit design. It operates below the threshold voltage of the transistor. And if you reduce the voltage operation, what is going to happen? All of you know very well that the energy is half CV square. If you don't, let me tell you, the calculation formula for energy is half CV square, energy stored inside a capacitor, and all these are capacitive structures. So energy is directly proportional to the square of the supply voltage. If you're reducing the supply voltage from 1.2 volts to 0.3 volts, you can just imagine how much less energy you are consuming, because it is dependent on square of that. So that's how we will reduce the energy consumed in the microcontroller unit. Now, let me talk to you about the radio and display energy problem. When you say radio, I already told you, we are talking about Bluetooth devices. So Bluetooth low energy. Bluetooth low energy, BLE, works in two modes. All of you have Bluetooth in your phones. You have Bluetooth in your headphones. Everyone uses headphones nowadays, Bluetooth enabled. They work in two modes, sleep mode and active mode. They consume 2 to 10 microampere current in the sleep mode, idle mode. And when they are active, they are working, they will consume between 10 to 30 milliamps of current. All right. And you say power, multiply that with the supply voltage, whatever you're running it on, you will get the power consumption. So the power consumption is reduced to the order of microamperes here in the sleep mode. Let us talk about displays. When I say devices, of course, I'm not going to talk about the 55-inch TV display. I'm going to talk about very, very small micro displays. I mean, the biggest display that is the display of a watch for you. I'm not even discussing, your mobile phone screen size. So I will say a 0.13 inch square micro display, a very small display. Where will you use it? You'll use it for augmented reality, and you'll use it in smart glasses. This micro display delivers up to 10 million nits of brightness. So the unit of brightness for this display is nits, N-I-T-S. And how much power does it consume? Just 60 milliwatts. Just imagine a display that consumes 60 milliwatts. And this is purely based on micro LED. This is the emerging technology. All right. A full big screen of a micro LED display will consume just 1 watt. a 55-inch TV of micro LEDs will consume only 1 watt. All right. So basically, we are reducing the power consumption in display, we are reducing the power consumption in radio, we are reducing the power consumption in microcontroller units. Even if you have reduced this power consumption, what have you done to the battery? I am actually taking you towards the technology where you are totally getting rid of the battery. I am showing you 3 devices here on the screen which do not have a battery at all. These are battery-free wearables. You can see Matrix Power Watch. It's a watch that will run body heat, solar energy. Now you may feel, oh, my calculators have been there for 20, 30 years and they are working on solar. What's the big deal of this watch working on solar? Fine. Let's neglect that. You can see a very small UV alert device. What is a UV alert device? It is going to just tell you the intensity of the ultraviolet rays falling on your screen. This was developed by NW University, Illinois. It is working without a battery. And the last and a very interesting one is the Infineon NFC payment ring. So all of you know very well that we can tap a card. We don't have to insert the card in the POS machine. Nowadays, you can even tap the cell phone, the mobile phone, because the card can be loaded inside the phone and you can simply tap the phone and the money will be deducted. But tapping a ring, amazing. All right. This is called as the payment ring by Infineon. You know what is the technology? The near field technology. Then in the ring, is there a battery inside that ring? No. Then where will it get the power from? It gets the power from this POS machine itself. The near field technology, which is going to connect these two, it will collect the power from that itself and it will turn on. All right. So it is going to feed the power from the device which is serving. Amazing. So let me now talk to you about what are the feasible sources of ambient energy. What I am trying to tell you here is, when I say battery-free wearables, I am telling you we are moving towards technologies wherein we will harvest energy. As you remember, the topic of my discussion is energy harvesting for sustainability. So I am going to tell you that we are going to harvest energy from our environment. How will we generate this energy from our own environment? What are the various sources? Please remember, energy can neither be created nor destroyed. The entire mankind together cannot create a microwatt of energy. All they can do is convert one form of energy into another. That is what it is. So what are the various sources? Photovoltaic cells, of course, solar. Everyone knows amorphous crystalline solar cells are there, which are the best source of energy. And I know there are a lot of speakers who have already talked to you about renewable energy. They must have covered these aspects. But frankly, the difference between my presentation and what is being presented by all the others is that I will talk to you only about milli and microwatts. I'm not going to talk to you about kilowatts or megawatts at all. Just excuse me, I'm drinking some water. Sorry about that. So we have photovoltaic solar cells, amorphous and crystalline. We have vibration-based energy harvesting. And of course, when we say vibration, we talk about piezoelectric devices, which can be capacitive or inductive. We can generate energy from radio frequency. All of us are surrounded by mobile waves. You would never go into an area or region where you are not getting mobile signal. So wherever you are getting a mobile signal, can you convert that mobile signal into energy? Can you convert that into electricity? Interesting. Let us see. we have thermoelectric conversion. This is a very, very happening thing. Of course, human power, wind, pressure. I'm not talking on human power, wind, and pressure. I will be talking about the first four, just briefly, a couple of slides on each one of them for you to understand what we are going to generate. But before that, the concept of power density. What is the meaning of power density? It means that per square meter, per square, not meters, centimeters. Just imagine centimeter. Hold a scale in front of yourself, 1 centimeter by 1 centimeter square. If you have a solar cell and you leave that 1 centimeter by 1 centimeter solar cell in the outdoor, directly under the sun's exposure, you will get 20 milliwatts. If you put a piezoelectric sensor in your shoe, you might end up getting 330 microwatt. Vibrations from microwave oven, the microwave frequencies will generate about 116 microwatts. And you can see the other entities are centimeter cube. What is the meaning of centimeter square and centimeter cube? Some are volumes and some are areas. All right. So thermoelectric at 10-degree difference of temperature is going to generate 40 microwatts. Radio frequency GSM 900 megahertz frequency band will give you 0.1 microwatt, and Wi-Fi. Everyone wants to have Wi-Fi, right? We are all sitting in Wi-Fi zones. Right now, my laptop is connected to the Wi-Fi, and that's the reason why I'm able to speak to you. But this Wi-Fi signal itself can be converted into energy, and it can generate 0.01 microwatts per centimeter square. Okay. So how is that happening? Let us see. It's all happening because of transducers. Probably other speakers might have touched upon transducers. So I'm just going to very quickly talk to you about that any non-electrical input will be falling on a sensing element, and that sensing element will be given to a transduction element, and we are going to get an electrical output. That's what is a transducer. Converts non-electrical physical form of energy into electrical energy. So what's happening with this energy harvesting system? In the previous system, this was an open loop system, but I prefer closed loop things. So let me talk to you about the transducer, the variable device, and in between, I have kept a red block, which is called as a DC-DC converter. You will all be surprised to know that whenever I am talking about low power devices, I am not talking about the supply of 220 volts AC signal. No, no way. I am talking about only DC power. So all the batteries that are there are pure DC. None of them is AC. All right. So how do you take this DC value, one DC value, and convert into another DC value that is required? That's happening from something called as a DC-DC converter. And that converter is controlled by a PWM, a pulse width modulated controller. All right. And I am going to briefly discuss how this is happening. All right. So this is a complete energy harvesting system. So if you want to sustain a wearable device, a low power electronic device, you need an energy harvesting system. And the heart of an energy harvesting system is what? A DC-DC converter. Okay. So as I told you, I will be briefly touching upon various thermoelectric energy harvesting devices. Okay. So first and foremost, what is the principle of working of these thermoelectric devices? It is called as Seebeck effect. We have studied this as fundamentals in our engineering and even probably at the school level. But we are applying this now to generate energy. If you take two metal wires, metal wires, they should not be same material. You should take two different metal wires, metal 1 and metal 2. And you keep the junctions of this at two different temperatures. All right. At one side of it, you heat it, and the other side, you again combine this and you place a multimeter or an ammeter. You will see current is flowing. All right. So it says that if you have two different layers, metals or conductors at different temperatures, then current is going to flow. This is the Seebeck effect. And you can see how small these thermoelectric power generators are. And they are getting or generating their heat from the human body itself. How that is happening? Let me show that to you. You can see about 1.4 microwatts per centimeter square of power can be generated using at a 5 degree Kelvin temperature difference. And let me tell you that thermoelectric energy harvesting, TEGs, is not a new concept. It has been there for like 20 years. In 2004 itself, the TEG, low power wireless sensor node, was introduced. And it was generating 200 to 330 microwatts at a temperature difference of 20 or 22 degrees Celsius. Now, where is it going to come from? As I told you, it will come from the human body. So if we are sitting and doing nothing in an AC environment, then probably we are generating about 100 to 150 microwatts, because our body, we are warm-blooded people. Our body normally is hot. And if we start walking, running, jogging, exercising, then our body temperature is going to increase. And because the temperature has increased, the temperature difference has increased, you can generate up to 500 to 700 milliwatt using the thermoelectric generators. That is great energy harvesting from only the temperature of our human body. A couple of slides on photovoltaic energy harvesting. All of you know solar panels, how they work. Photons will fall on the semiconductor material of PN junction diode, and it causes electrons and holes to move from the anode to the cathode. And that's what is the generation of current. I mean, we have been working on these solar panels for ages now. But I am talking to you about micro-sized solar panel. This is a $1 coin on which I have placed a SIMBET Ener chip. Ener chip is an energy chip. You can just see how small it is in size. It is already a product in the market. And what all are the things? If I just blow up that image into a bigger size image, you will see that there is a wireless transceiver sending and receiving signals. There is a solar cell which is going to charge this. So this will not have a USB-C cable charger or anything. Nothing will connect to it. It will automatically get energy from the environment. You have an inverter, you have sensors, you have MEMS pressure sensors. All right. All this together is existing, and it is called as SIMBET Ener chip. Now, the third thing, in fact, I want to talk to you about is radio frequency. How can you generate electricity from radio frequency? And it is already happening. All right. Powercast is a company, and you know what a beautiful representation of this. Can you see that this is Wi-Fi signal or communication signal? This is how we represent signal, right? So this green energy, which is all around us, is being converted into plug, which is electrical energy. All right. This is by a company called as Powercast. They convert radio waves. How can they do that? These radio waves are nothing but, you could say, sinusoidal kind of waves. They will fall on an antenna. And I think every one of us know how an adapter works. How does a power adapter work? You will have an AC signal coming in, and that AC signal is given to a rectifier bridge circuit, diode rectifier bridge circuit, a transformer and a diode rectifier bridge circuit. Exactly the same thing is going to happen here. The AC signal from the radio wave is going to fall on the antenna, and then it is converted from RF to DC conversion. Then the power is conditioned and given to the output load. What is there in RF to DC converter? Same things. You have got 4 diodes, which is going to form the bridge structure, and you will have a capacitor and you have a load. All right. What is the difference then? This is working on 900 megahertz for cell phone signal. It is working on 2.4 gigahertz for Wi-Fi signal. So you are generating power or electricity from cell phone signal and Wi-Fi signal. All right. This is a 3 chipset powercast energy harvesting circuit that you can see here. Very, very small in size, 1.3 centimeter square. All right. And it generates from 2 volts to 5 volts. All right. It works on a frequency of 1 megahertz to 6 gigahertz. You know what is the frequency of our power adapter, your laptop charger? 60 hertz. Because that's what is the AC signal coming into our home. And what is the AC signal coming here? 900 megahertz, 2.4 gigahertz. Very, very high frequency AC. So that has to be converted. That RF signal has to be converted into a DC signal. Okay. So that's a radio frequency transducer. Next is a MEMS vibrational energy harvesting sensor. What is the principle of MEMS? Micro electromechanical sensors, MEMS. This is on the principle of a cantilever. Cantilever is nothing but, I mean, you can imagine that there is a rod which is fixed at one position and which can be moved at another position. So it is just that on this side of it, this is fixed, held, and on this side of it, if you move it, vibrate it due to some mechanical energy, this piezoelectric crystal is going to get pressed, and when it vibrates up and down, it generates electrical signal. All of you know very well that piezoelectric crystals can convert electrical to mechanical energy and mechanical to electrical energy. So those of you who are in hardcore electronics, they know that all the oscillators, signal generators will have piezoelectric crystals in them. The reverse is also correct. So MEMS sensors, which can be put inside the shoe sole, it can be put inside the socks. These have this kind of a very, very micro cantilever mechanism, and we can generate power from them. In fact, Bolt is the name of the company, which is generating 3.3 volt DC and about 1 milliwatt of power, 0.1 to 1 milliwatt of power. These devices are already there in the market. Micro power generators is what they call. And I have covered these 4 for you. I have talked about thermoelectric. I have talked about photovoltaic, the solar. I have talked about radio frequency and MEMS. Let me now compare all these 4. All right. So if you look at the energy density, you will see that the lowest energy density is for the RF power. You know, from the cell phones and from the Wi-Fi signal, it's the lowest energy here. The next one is the vibration, piezoelectric. You can see it's in the range of about 10 microwatts, goes up to 300 microwatts. And these piezoelectric can be either piezoelectric, electromagnetic, or electrostatic or capacitive. Okay. Then we have got thermoelectric generators. Thermoelectric generators are in the range of 10 to 100. And finally, we have got solars, which vary from 1 to 15,000 microwatts. All right. 15,000 into 10 to the power of minus 6, you know, is going to be 0.15 or 0.015 watts. Okay. So this is the, you could say, energy harvesting comparison of all of them. So what will you say? Okay, I will use solar. That's the best. But the question to you is, do you have solar available all the time? What if during the night you want to charge your watch, which is running on solar? There's no sun. You'll say, I leave the light open. Can your watch charge from the light that is there from the room? Yes, it may, but very less. And why will you leave the light open, switched on, while you're sleeping? So you want, while you're sleeping, your device should get charged automatically. So solar is not always the best option. In such cases, we might have to go for the other options like thermoelectric generators, piezoelectric generators, or RF generators. Okay. After discussing these four, I wanted to talk to you about a little bit of theoretical concept, which is called as the maximum power point tracking, MPPT algorithm. Now, everyone in electrical engineering, electronic engineering, or with the engineering background will know the maximum power transfer theorem, in which it is said clearly that maximum power will be transferred when the source resistance is equal to the load resistance. RS is equal to RL. All right. And this is one particular point when RL and RS will become equal. So RS is equal to RL is a point where you can say it's 1 here. RL by RS is 1 means RL is equal to RS. At that point, maximum power will be delivered to the load. Okay. So this calculation of the maximum power point tracking is very, very important. All right. So I have talked to you about the different types of energy harvesting, calculation of memory power MPPT. And now I will finally take you towards energy storage. So all this power that is getting generated, you can use it immediately or you can store it to be used later. There are two ways. You're getting some power, immediately use it. Power up an LED or power up a microprocessor or whatever. Or you can store this energy. I have seen the schedule. Some of them, one of the professors have already talked to you about energy storage devices. But I'm sure they must not have talked about very low energy storage devices like what I'm going to discuss now. Okay, so these very low energy storage devices, how are they going to work? Probably on radiation, chemical, electrical, temperature, kinetic, whatever. So let me show you that the energy storage devices, especially lithium ion, LiPo, NICD, NIMH, all these batteries, slowly are getting drained out. Okay, Tesla, BYD, these are the cars that are electric in nature. The entire car chassis or the bottom floor is full of batteries. All right, and they are guaranteeing about 7 years of battery life. After that, the battery will lose its efficiency and you have to change the entire floor. Costs about $15,000-$20,000, I'm telling, but it's as good as getting, half the car, because the entire car, electric car, is working on the principle of these batteries. And these batteries will automatically wear out and they will lose their life. All right. So when I say these storage devices, we have to do something to improve our storage, which could be ultra capacitors, micro supercapacitors, fuel cells, heat engines, so many different options. All right. So we can see here that in-chip capacitor, supercapacitor technology enables storage energy of 0.2 joules. All right. 0.2 joules can be stored inside this capacitor. All right. Back to our MAX 32620. You can see a lot of components here. I'm just keeping this as a reference for you, just for you to understand that the power requirements inside this are first and foremost control. Control means microprocessor, which is the ARM M4 Cortex, ARM Cortex M4 series. At the top, you can see this is the brain. This is the sensor. I'm just trying to give you an example of human body. This is the sensor. So you have got your eyes, ears, nose. So you've got your sensors here, ECG sensor, temperature sensor, whatever sensors. Then this is communications. It takes energy for you to speak. It takes energy for you to listen. That's what you do, communication. Or you want to signal someone by hand, come here, go away. That will also take energy, moving your hands. All right. So that is communications. Bluetooth, low energy, and GPS are the options there. Then we have got the user interface, which is the screen. And that is very, very important, because where are you going to press the buttons on? So that's really very important. And finally, you want to see what's happening. And that is what is the display, or the LCD or OLED. And of course, I talked to you about storage, because that's an integral part. And you will be surprised to see that each one of them is working on a different voltage. They are not all of them working on 1.8 volts. No. You have a 5 volt LED, a 3.3 volt analog, 1.2 volts digital. So the analog part is always running on a higher voltage when compared to the digital part. All right. Communications, it will run on 1.8 volts. Processor works on 1.8 or 1.2 volts. User interfaces on 3 volts. How are you going to get these 12 volts? All right. Display is requiring 12 volts. Where do you get 12 volts when you are giving 3 volts itself? This is where the DC-DC boost converter is going to come into picture. And I'm going to cover that up shortly. The architecture of the variable device. You can see that you've got your 5 volt or 3.3 volt adapter, which you will connect to the wall. Wall adapter means the adapter will connect to 110 or 220 volts and convert into 3.3 volts. All right. This is going to connect to what are all the devices? Your processor, display, LED, sensor, Bluetooth. You will see that for each one of them, there is a DC-DC converter. Can you see DC-DC boost, DC-DC boost, DC-DC buck? I'll tell you what is the meaning of boost and buck converters, but essentially you have to understand that whatever there is a block, it needs power and it comes through a DC-DC converter. Okay. And I'm going to just discuss very briefly what is the difference between a buck and a boost converter. Okay. So if you look at the block diagram of power management unit, you will see you've got sensors, RF transceivers, switches, boost converter, maximum power tracking, MPPT. That's very, very important. And your energy is getting harvested from where? From the sun or from temperature, TEGs, or we have just studied from radio frequencies, whatever. This is the energy harvesting. And that energy is going to go inside the chip to run this chip. Okay. So what we have realized is that we need to at least understand very briefly what is a DC-DC converter. So if you are from electrical engineering, you have definitely studied DC-DC converters. If you are from electronic engineering, there is a doubt you have not studied DC-DC converters, because it's coming in power electronics and a lot of students or teachers, or it's a faculty development program, you have got teachers, you will not know about what is a DC-DC converter. There are 3 types: boost, which means step up, voltage increases; buck, which is step down, voltage decreases; and buck boost converters. All right. So what is inside the step up boost converter? You will see a very, very simple circuit. You've got a supply voltage, you've got an inductor, a switch, and your diode. That's a very simple switch mode power supply, SMPS concept for a DC-DC boost converter. Okay. So the essence or the important part for this is the inductor. All right. And your diode. So for every DC-DC boost converter, it is very, very important that you have something called as PWM, pulse width modulation. A PWM signal is required. This is how we are going to generate a PWM signal using very, very small components like CMOS design. Can you see all these small transistors? The top transistor is a symbol for PMOS and the bottom is a symbol for NMOS. All right. So this is what is a simple chip inside which we have got NMOSes and PMOSes, and it's a PWM based boost converter. You all have seen that a very important concept here is an inductor. You cannot harvest energy and use it without a DC-DC converter, and you cannot get a DC-DC converter unless until you have an inductor. And inductors are bulky in size, they are big. So what is doing? We are going to try and manufacture inductors. All right, make our own inductors. How? On a chip, if you are going to draw a coil, that will generate a small amount of energy. All right, so that is off-chip converters. Then we also need to understand that there are different types of inductors. Okay, what are the 4 types of inductors? Conventional, coupled square, coupled octagonal, and coupled square white traces. So let me just show you how an inductor can be made on a PCB board. You do not have to physically hold the inductor. All right, just you can see a conventional inductor, coupled octagonal, coupled square with wide traces. All right, so these are all the images of inductors that are fabricated inside a VLSI design chip. Okay, and how do you design the DC-DC converter? As I already told you, you'll use inductors, you'll use capacitors, you're going to use semiconductor devices, and we are going to monitor what is the loss of the energy after conversion. So conduction loss, gate power loss, dynamic loss, these may all typically arise. All right, and for each one of them, you have got a formula. Can you see that the formula for power loss of any device is already defined as CL plus CG plus CGP VGS square F plus IL square D, which is duty cycle, times RDS on plus 1 minus D into RDS on plus R. All right, so this is the formula for the power loss that can be gauged, which is very, very small. You can see the overall thing is very small. All right, so the upcoming cases, I have just given you a brief idea of how a circuit is made, how a DC-DC boost converter is made, what is there inside the complete power management unit, and how energy is getting harvested. And the upcoming challenges that you can see are, you could say, future challenges that of an embedded coach. What is an embedded coach? This is an interesting concept. If you are wearing a watch, it is going to sense your heart rate. Now, that heart rate, does it send every second, or can it take a decision on the watch itself by monitoring the data and then discarding it off? So everything is normal, you will not send a signal. If that you see that there is some kind of an abnormality, you will immediately send a signal. So what we are doing is, we want the ability to process locally. We don't want to just take the data and send it out. All right, that is a very important channel. And the other is intelligent variables. You can use activities like applications like activity recognition, skill assessment, gait analysis, all the different emotional recognition, like a person is smiling, angry, all that can be detected by making use of wearable devices. And a lot of neural networks, AI stuff is going into this, and you will need a lot of processors. So the future definitely is very, very challenging, and we are looking at wearable power management devices for energy harvesting and very low power consumption. That was the complete crux. I would just like to conclude by telling that the energy harvesting technologies are improvising a lot, and there are many different areas. In fact, a few of them are already covered here in your FDP. I have seen fuel cells is there, thermocouples are there, all right, photovoltaic is there. So there are different areas from which we can generate energy. But when we talk about low power, we will use very few selected avenues, and most of the world's energy in future will be generated using these energy harvesting techniques. And we will not be charging the devices, they will get automatically charged. that is what is the concept that I wanted to talk to you about. These are a few references, and I would like to close my presentation with that. I hope I was able to give something which you are able to understand. If there are any questions, I can take them now. Over to you, Hajar. Hajra, are you there?
Arif sir,
Yes.
I am Nida Yasmin, assistant professor at Manu. I have a doubt, sir. Sir, you have
Yes, please
shown
go ahead.
the formula of power.
Yeah, half CV square.
Yes, sir. Sir, in that, what is the
Duty cycle.
duty cycle of the input signal?
No, what happens is the power, I mean, voltage, we are not going to give a constant DC voltage.
Yes.
We are going to give on, off, on, off.
Yes, sir.
There is no need of completely giving on. If you give that, it means you will always continuously consume power. So give on, off, and that will give you on time by off time plus on time, total duty cycle.
Okay, sir, one more doubt. You have shown a circuit that included inductor and a diode.
Yes.
So, we are switching on, like on off. So
Yeah.
just to generate the AC inside the inductor. That
No,
is
no.
the reason, or then how
No,
the inductor will give us the AC, sir? Because if for the inductor, if we don't give any changing current, it won't work as inductor.
Yeah. So basically, this is the concept of a switch mode power supply, and we are going to switch the. There will be a switch that will continuously keep changing. All right. So we are not going to pass current through the inductor. I mean, like a DC, in which case it will behave like a short circuit. So inductor is going to store energy, and we are going to, yeah, Mr. Bashir. Basically, DC-DC boost converter is a little bit of a detailed concept which I may not be able to explain in this short duration. In fact, I had a complete video of how this operation is happening, but due to paucity of time, I will not be able to take it up. Perhaps you can look it up. You have a lot of YouTube videos also which give you how a DC-DC operation is happening, but it's important for you to understand.
Any more
Any other
queries?
questions?
Participants, if you have any other questions, you can please go ahead. So I take it as no questions for them. Thank you, sir. Good evening once again. Good evening, everyone. As we conclude this enriching session on hybrid renewable energy systems, it is my privilege to propose a vote of thanks to our distinguished speaker, Dr. Mohammad Arifuddin Sohail. On behalf of Maulana Azad National Urdu University, the organizing committee, and all the participants of this faculty development program, I extend a heartfelt gratitude to Dr. Mohammad Arifuddin Sohail, sir, for your insightful and engaging session on hybrid renewable energy systems. So your session has not only enriched our knowledge, but also inspired us to explore innovative approaches to tackle energy challenges in today's world. We are truly grateful for the time and effort you have invested in preparing and delivering such a valuable presentation. Your passion for teaching, combined with your research and industry experience, has left an incredible impact on all of us. Once again, I thank you, Dr. Arif sir, for your invaluable insights, and we sincerely hope to have you with us again in future for more such inspiring sessions. Finally, I would like to thank all the participants for your active involvement and keen interest in the topic, making this session even more meaningful. Thank you, everyone. The participants
Thank you so
will
much for the opportunity. I appreciate that.
welcome, sir. So, dear participants, we'll wait for 5 minutes. We'll have a break of 5 minutes, then we'll start off with the next session.
I'm going to drop out now, Hajra. Thank you so much.
Thank you, sir. Welcome back, dear participants. Our resource person has already joined. So we'll start off with this second session of today's FDP. The resource person for this session is Dr. K. Radhavendra Reddy. It gives me great pleasure to introduce our esteemed speaker for today's session, Mr. K. Radhavendra Reddy, an accomplished professional with over 14 years of diverse experience in the energy sector, particularly in renewable energy and solar power projects. Mr. K. Raghavendra Reddy holds a bachelor's degree in electronics and communication engineering and a master's degree in VLSI embedded systems, showcasing his strong technical foundation. Throughout his career, he has worked with leading organizations such as Suntech Energy Systems, Solar Town, and Radiant Solar, taking on progressive roles from technical engineer to head of projects. Currently, he serves as the head of projects at Energy Systems Private Limited, where he oversees end-to-end project execution with remarkable expertise and leadership. His contributions have been widely recognized with laurels including Best Employee of the Year award twice, Best Performance of the Year award thrice, and recently the Best Team Award from EQ magazine conferred by Surya Khan. Dr. Reddy has a proven track record in successfully managing large-scale solar and renewable energy projects. His insights into energy management, project execution, and team leadership make him a valuable resource person for today's session. In this session, he'll be sharing his expertise on hybrid renewable energy systems, and I'm sure his practical knowledge and real-world experiences will inspire and educate us all. Now I welcome Dr. K. Raghavendra Reddy, sir, to take over the session.
Excuse me, sir.
Hello.
Kindly just share your window of the presentation. You are
Yeah,
sharing
one-
your entire screen.
Yes, 1 minute, 1 minute. Just a minute.
Okay. Sir.
Mirror.
So just stop sharing your screen for a moment.
Yeah.
Now, when you try to present your screen,
Okay.
when you click on the present now,
Yes.
on the in the tab there are 3 columns above.
Yes. One is Chrome tab, window, and the entire screen.
Select the window.
Yeah, I'm selecting the same window.
In that, select only the PPT part, not the Google Meet.
I'm not able to see. 1 minute. Yeah, got it. 1 minute.
Yes, sir. Now it's yeah.
Now it's okay.
Yes, yes, sir.
Can everyone can see this screen, right? Now? Yeah. Yeah. Good evening to all. This is very means this platform is very honored to me and giving this opportunity. And going it, yes, I want to present on the topic hybrid renewable energy resources. As Madam introduced me, my name is Raghavendra Reddy from Suntech Energy Systems Private Limited. I am the head of the projects for the C&I and domestic. So now I'm going to the topic hybrid renewable energy systems. So nowadays, the energy resources are very essential to our living means manpower, living sources for this. So energy is the most useful things in our day-to-day life. Without energy, we are not able to survive. We are in the earth. So like that, we are accommodated energy of utilization, like electricity for a multiple purpose in general, our general use. So, but to generate this energy or electrical power or electricity from this, we need a different sources. We are generating the electricity with the different sources. Mainly, previously, traditionally, we are used to generate electricity from fossil fuels, the non-renewable resources like fossil fuels and the thermal, all these things. But these resources are getting exhausted and getting limitations, and also which cause a lot of environmental pollutions. And so most of the now to avoid this, most of we are interesting to go for renewable resources. Using the renewable resources, we need to generate energy power or electricity, and for the general users, whatever the energy we can extract from the renewable users, we have to make that availability of the renewable resources, and we have to create the energies. So this why we have to go for the renewable energy resources. The renewable resources are very economical friendly, which uh, avoids the pollution, and also which is we have means when we use, so it will be available throughout the life. So it will not be exhausted in a lifetime of span, in a span of life. So now in this, so what is the actually hybrid energy system? Hybrid energy system is an energy system that combines two or more resources to generate electricity or power for uninterrupted utilization. So like energy resources like renewable and non-renewable resources, fossil fuels and solar and wind energies. Mainly the energy resources are classified into non-renewable and renewable resources. The renewable resources are resources uh, which is replenished and which is not means which is available full life of span, such as the solar, wind, and geothermal, so biomass and all. The mainly renewable energy system aims to produce sustainable and environmental friendly energy supply. Non-renewable energy systems. Non-renewable energy systems are energy systems that utilize non-renewable resources like coal, petrol, fossil fuels, oil, all these things, and produce energies. So which is So not we can call as a not a environmental friendly resources, and which we can see that rights of the figure when we go for the renewable energy system, our earth will be green and the means eco-friendly. And if you see the downside, if you use the non-renewable resources, the earth will become the like a means our life will be it will become a very tough, and it is very difficult to survive with the different pollutions. These
Excuse
are
me.
the yes,
Sir, have you started sharing the slides?
yes.
No, we were able to see just only the first slide, the introduction one.
One. Oh, is it? Oh,
The slides are not getting.
sorry.
Yeah, now we got.
Okay, I made a slideshow, but the slideshow is not coming.
No, sir. Now we have got the next introduction slide.
Yes. Oh, sorry, all these slides missed. Huh? Yeah. Can I continue from starting, or you want me to continue from this?
You can continue, sir. No issues.
Yeah, renewable resources. We can see the type of renewable resources, different types of renewable resources: wind energy, hydropower energy, solar energy, and geothermal energies. And non-renewable resources: oils and coal, nuclear, and natural gases. The types of renewable energy resources: hydroelectric energy resources, or we can also call it as hydropower. It is the most widely used power resources, which is used to generate the energy with the water flow. The use of gravity potential elevated from the water flowing through the dam is rotate the turbine of the hydraulic turbine, and which coupled with the generator. The generator will generate the electrical power. This flow of water will create the hydraulic turbine to rotate, and which is connected to the generator. The generator will generate the energy. This is using the water resources. This generation will be takes place, the power generation. The main advantage of this is the lower operation cost and less maintenance is there. So this again, the whatever the water is there, that can be utilized for the irrigation or water for supply of water to agriculture, irrigation, and whatever the other utilization of water we can utilize. And by building these dams, we can also avoid the flood control. So regular plenty flow of water we can control by constructing the dam, and that same dam can be used for the generation of electricity with the hybrid hydroelectricity power. So mainly the disadvantages is the infrastructure for the building and making this dams construction and construction of hydraulic turbines, and this will be very expensive compared to the other resources. The main application of this hydro power is for generation of electricity. The next, wind energy. Wind energy is the second most wide technology used to generate the electrical power in the world. So this is used to the flow of wind will spin the turbine's wings, and which is connected to the generator, and then generator will be generating the energy. So this flow of wind to the, we can call the wind energy to the electrical energy conversion. So this is a renewable resource. So the main advantage of this is so we can means it is a we can utilize a lesser land for a installation of these wind turbines. And even though the wind turbines of the installation land will get the rent and rent for the land and utilization of for the wind turbines. So as for landowners or farmers will get affected, benefited with these things. And even they can also make the farming excluding that areas. So which is not affect the lands. The disadvantages is like when they rotate in the wind, the wildlife and birds, whatever the birds are there, that may get the affected or that may get spoiled due to the rotation of the turbine and all. And also the disadvantage is the wind, whatever the wind flow is not consistent. So it is sometimes the wind flow will be less, sometimes it will the more, and so due to this, the generation power is not a unique. So wherever the application of this electrical power generation, and next pumping groundwater by using the windmills. Windmills will be connected to the motors from the push the water from the ground. Next source is the solar energy. Solar energy is generated from the solar power panels, so which is also called photovoltaic panels. The photovoltaic cell is made up of silicon cell that convert the sunlight energy into electrical energy. So the electrical energy can be utilized for the charging the batteries or for the utilization of domestic utilization, and the using the inverter resources. We can also use for the higher voltage level, like for the transmission of industries, etc. This is mainly we can call it as the solar power is the most utilization of third resource in the world, which is reduced what is advantageous is that which is the reduce the household electricity or industrial electricity bills even to the zero level, and easier to install, and which controls the carbon dioxide emissions and all. The disadvantage is the cost of the installation little bit more. And the second thing is whenever the cloudy generation, cloudiness is there, that time the generation will be lesser, not expected level. So mainly the application of this is to generate the electrical power, and also we can see that using the thermal solar, we can also use the cookers to cook the food. There is a solar cookers which use it to cook the food, and even the fields we can run the direct motors, electrical motors directly with the solar. Whenever the sunny day is there, that time we can run the solar. Next is the biomass. The biomass energy is which we can produce by using the burning burning the biomass substances like animal waste, plant wastes, and burning the woods under the ground for the making and like a cow dung also we can use for make biomass energy. So this main advantage is that bigger this resources is biggerly available in our nature. Even in our day-to-day life, we are vegetable waste, garbages, all these things are available, plentifully available that we can use for the biomass. The disadvantage is during the biomass we will using this burning of the wood or burning of the this wastage, it will lead to atmospheric pollutions, and this is the main advantages for biomass. This biomass applications are production of biodiesels and alcohols, and even for electricity and generating heat. Geothermal. The geothermal energy is generated from the earth. So the heat captured by pumping the water in the depth of the earth. So the water is evaporated with the earth heat. The evaporation from the evaporation, the wind due to the evaporation, the wind turbines get rotated, and that will be connected to the generator, which generates the electricity. But the water, this the geothermal is required to drill the more depth to get the higher heat and the earth. So this is a disadvantage. There is we need to use the model drilling technology to limit the uh, continuous drilling of these things. The earth will get affected, and whatever the earthquakes we are nowadays we are affecting, this may cause to earthquakes and all. So main application of this is electricity generation. Next is hydrofuel generation. The hydrogen gives a more heat compared to the carbons. Therefore, the hydrogens are used for their fuels in the like automobiles and general things. So this hydrogen, the advantage of this more is that more efficient than compared to all other resources. The disadvantage is this is a very expensive, and this hydrogen fuel is highly inflammable and explosive. The storing and carrying of these hydrogen fuels are very difficult. So this utilization is means using this, it is difficult to generate the means we can suggest using of this is a very difficult for generation of electricity or energies. The next is the ocean energy, or also we called a ocean tidal energy. When the in the oceans, the tidal when we the waves will be generating when the waves are there. When the waves are created in the means oceans, the turbines will rotate with the waviness of the water, and that connected to the generator. This will generate the electricity from this. The advantage of this is lower operation cost. Just we need to install on the water, then there is no need of that general operations and all. It is just for install and forgot to process. But disadvantage is the machinery and equipment is required more larger number of machineries and is required. So the power generation we need to reach the specific generation means we need to install the more number of machines to get the proper generation. So to all these things are renewable resources. So which is due to be energy for the generation of energy resources. This now now we are coming to the topic. Main topic is hybrid energy resources. Sorry, energy system. The hybrid renewable energy systems. What are the now we discuss the renewable resources? The utilization of two or more renewable resources for the energy generation is called a hybrid energy system. The hybrid renewable energy system is combination of multiple energy renewable resources and to produce constant and reliable power resource. This is the basic principle of this renewable hybrid renewable resources is to combine the multiple sources without associating limitations. Limitations. Some system is having some limitations. Some renewable system is having some limitations. Like suppose solar is having the only nighttime limitations. Nighttime it not be producing any power. It is a zero power. And wind turbines. Whenever the high wind pressure is there, that time only it will generate the more power, and the wind power is not there, then the generation from the wind turbines is zero. So to resolve all these things, the best idea is for the going for a hybrid system. So using the renewable systems, making the hybrid is called a hybrid renewable resources. The examples for the solar and wind, and solar and hydropower, hydropower and wind, solar, thermal, and biomass. These are the four examples, and for the hybrid renewable energy systems. So we can see the hybrid renewable resources like solar, wind, hydrogen power are combinedly used to make a hybrid system and to generate the power for the necessary needs. Now we can go for the solar energy plus wind energy. The hybrid renewable energy with the solar and wind. The wind solar energy systems make a combination of PV voltaic, means solar panels with the wind turbines to produce electricity. This integrates the extremity efficiency and beneficial. This integration is very extremity. So as we discussed in the worldwide, the second most we using the renewable resources is the wind, and third most using the renewable resources is the solar. So combination of these two renewable resources will give the better benefits for unstoppable energy and utilization of maximum energy for the necessaries. Since it allows the energy production in various times and day and in various weather conditions, and production of maximum overall energy output. Like the wind is there is anywhere we can install the wind turbines. Like there is no limit to so installation of wind turbines, and even the solar also anywhere, wherever the sun is there we can generate a solar energy, and wherever we can get the wind we can generate the solar energy. Just 1 minute. Sorry for inconvenience. Yeah, solar and wind energy. So this combination of this combining of two renewable energy systems is a very useful, and the solar panels use the lighting use the power during the day, and the wind turbines use the wind energy during the night. So even whenever suppose the solar is installed, then that person or that company or that system is required the night power, then there is no use of installation of solar. If we combine the wind and solar, then the wind also will generate the night time. During the night time, they can utilize that energy from the turbines, which is generated from the wind. So this hybrid solar and hybrid energy system help industrial use energy smarter by adjusting the local weather and environments. So this is a one single schematic, simple schematic drawing how the wind and solar power will work, and even along with that biomass this energy sources also is there. Just I will explain this schematic. The The wind turbine will generate the energy, and this inverter. Suppose if there is a two types of wind turbine, there is a AC wind turbine and DC wind turbine also is available using the DC generators and AC generators. So whenever if it is a DC generator, wind will be used inverter, and that converts into AC source. Parallelly, the PV, the solar energy resources also will generate the DC, and when it comes to the inverter, the DC is converted to the AC, and it is connected to the control panel. Even from the biomass, the generator will generate the AC generation, and it is connected to the control panel. All these resources are used parallelly. Means there is no like that. If it is required, if it is power is exceeded, that can be utilized for any other. Or if we want to stop the resources, we can also stop the resources if it is power is exceeded or more than the necessary. Then from the control panel, it is going to the batteries. So why I use the batteries is, it means suppose the generation is the more, then that batteries will be get stored, and whenever these resources are not available for the utilization, the battery bank will support to back up the power for the utilization uses. So this is another schematic drawing which represent the solar and wind. So now, as I explained, why we have to go for the hybrid energy resources. What is the reason for developing a hybrid energy resources? Why can't we use a single resources? Why can't we have to go for hybrid, multiple inverters combining the multiple renewable energies in a single place or single system? So hybrid renewable systems can we activate the intermittent problem of individual renewable resources and can improve the overall reliability and stability of the energy production. The main is that the energy reliability and stability is the main requirement for the energy resources, energy equipments. There should be a stable energy production and there should be a reliable energy production. So these hybrid renewable energy system will produce reliable and stable energy production with this hybrid system. Means, and for example, the combination of solar and wind, where the solar systems reaches the peak output during the day, and the wind energy can utilize the weather when the solar energy supplies is reduced. The solar, if you come to the solar generation in the morning time, it will be lesser. The graph will be, it is like a parabola. When the morning times, it will be, even we install the more capacity also, the morning times it will be lesser generation. As soon as it is reaching the time, if it is a sunny day, is getting by afternoon it will reaches the maximum generation, and again maximum generation too, it will come down by evening. So whenever the maximum requirement is there in the morning and evenings, using the single resources is difficult to reach the and require necessity. So we will use another alternative for combining renewable resources. This will this will useful to get the stable energy utilization of for the energy resources. Moreover, the hybrid renewable energy systems are often combined with energy storage systems. So not with the single, if we combine with the energy storage systems, whatever the energy production is exceeded, that is stored in the battery systems, and which give a backup whenever there is no energies from these resources. As per this connectivity, these hybrid renewable resources energy systems are classified into three categories. One is grid connected, off grid, and microgrid. grid connected system. The hybrid renewable systems are directly connected to a centralized grid. Centralized grid means whatever the electricity, now whatever the departmental electricity will come, there we can connect directly to the central grid. The main advantage of this central connected system is that the easier to implement and take advantages of existing grid infrastructure. Using this existing grid infrastructure or departmental grid means the electrical power, the electrical utilization of the electricity from the departments, whatever we are getting, that is department power, that we will utilize and take a reference, and this on-grid system just they will take the reference to generate the electricity, and they will generate the power and push to the electricity department or electricity divisions. So it is just a simple method. It is just easy to connect for the utilization. There is no like a major expensive to compare to the all other connecting systems. So like here we can see this one small picture. So wind turbine, wind inverter, and solar panels, solar inverter, and that will be connected to controller or combiner, and from there it is connected to the directly grid. So there is the energy meter or electricity meter, a departmental will there, which is a smarter meter, which we call as a bidirectional meter, which shows the whatever the which reads the energy from one both the directions, the positive direction or negative direction. So it shows we can also call as a net meter. So whatever the generation is happening from the solar renewable resources like a solar, wind, or any other resources, it will be recorded when it will go through the departmental grid or grid, we can say grid. And when we take the energy, if electricity from the grid, and it will record the whatever the energy units, how much we are consumed from the grid. So this net will be calculated for the billing of the electricity. Next is the off-grid system. This is also called as a standalone system. Standalone system means without any external reference, the energy will be generated and stored, utilized. These systems operate independently. There is no depend upon the grid. So this system can be used anywhere, remote areas, or somewhere we can anywhere we can use this system for the utilization of power. These are off-grid hybrid renewable system. It typically required energy storage systems to store the power and can provide the energy independence when the renewable energy systems are not generating the power. So this system mainly utilizes the batteries. Whenever the generation is there, even from the wind or from the solar, the generated electricity will be stored in the batteries. And whenever the required, the energy is required for the resources or for the utilization, that time the energy will be drawn from the batteries. If solar will charge the batteries in the sunny days, and wind turbine even days and even night. So it depends upon the air flows. When the wind is there, that time it will produce the energy and it will charge the batteries for the utilization. Next is a microgrid. Microgrid is a combination of grid connection and off-grid system. Grid connection and off-grid system. In microgrid, even we can see, so in the full village we can connect with renewable resources with a microgrid technology. So here the storage and storage devices also will be there, and grid support also will be there. So microgrid systems are between the grid connected and off-grid systems. This system can be operated independently or using the batteries. This combination of multiple types of renewable resources and energy storage, the microgrid systems are highly flexible and can provide a realistic event. When the grid failure also, it will support. It it is called a uninterrupted power we can supply with using the microgrid system. Even we can light up a small villages, remote area villages with this microgrid technologies. So now, what is the benefits? What is the benefits of hybrid renewable energy resources? The main benefit is the increasing energy efficiency. So if you use single means individual renewable resources, there is a less efficiency of energy production. If you use this combination of hybrid energy resources, then it will give the more efficiency. And you means using the lesser area, we can get the more output from the little means smaller area. So then we can get the more efficiency to compare to the individual resources. Improving the reliability. The hybrid system can provide the stable energy supply even when one source is not available. So in hybrid systems, there is a multiple energy systems, so which is connected. So if it is one energy system is not available or which is not producing the energy, definitely another system will utilize for the energy generation. This is useful for improving the reliability of the reliability. Reduce the cost. So reduce the cost for installation or making the initial investment for the establish this renewable energy resources. For individual, it will cost more compared to the hybrid renewable energy systems. In a hybrid renewable energy systems, so for cost reduction, we can use the same space for the both means multiple resources. In a single location, we can use the multiple resources, even for the maintenance or even for the manpower. So it is a single place we have multiple resources. Then with the maintenance of this cost will be reduced. Next is the environmental benefits. Hybrid system can reduce the greenhouse gas emissions and promote the sustainable development. It will reduce the environmental benefit. So reduce the means more utilization of hybrid renewable resources. There can be reduced greenhouse gases emission and flexibility. Hybrid renewable energy resources can be designed to meet the specific energy needs and can be easily integrated with the existing energy infrastructure. So these hybrid energy resources can be established anywhere or can be connected with any resources to generate the power. Applications of renewable energy resources. Rural electrification. This, as we discussed earlier, in the remote areas, even nowadays, there are some villages which don't have, there is no provision to make a transmission lines for the electricity. There we are using the solar energy systems and wind turbines, like a battery turbine, battery systems, like making a microgrid, and their government is producing the electrical power for those villages where there is no provision to transmission power from the generation point to the villages. This is a situation where we can use this renewable energy systems to electrify that like that villages. So Iceland communication. So whenever this Iceland, which is a means not link up with the existing lands and all, there we can use the hybrid renewable resources. Then so we can make their energy make use of electricity, and we can communicate with the Icelands. Industrial applications. Nowadays, the every industries needs a power for the generation of all they make the production and to make the finishing goods to meet this domestic demand. So we are using even non-renewable resources, renewable resources. But this using the hybrid renewable resources is a very uh, good thing to go with the hybrid renewable energy to give the uninterrupted power. So whenever the is industrial power is converting the people are converting the hybrid renewable resources, that time the pollution of the maximum pollution is controlled, and this will give the clean and renewable reliable energy for the industries. Residential applications. Providing energy efficiency and sustainable energy resources for the homes. So even the wind turbines also nowadays we are getting the smaller in size. Even we can generate with using the 1 kilowatt and 2 kilowatt wind turbines, and the solar system with a 2 or 3 kilowatt wind turbines. So like that, if you install 2 or 3 combination of these resources, so we can so no need to depend on a grid, so departmental grid. We can only means standalone system. We can generate and we can produce electricity from our own. So these are different energy technologies and benefits and applications. Wind and solar hybrid, continuous power and better land uses, electrification of rural areas and villages, biomass, utilization of organic waste and supports the circulation of economy. So whatever the organic waste, vegetable garbages, all this organic waste will be utilized for the generation of biomass energy and supposed to circulate the economy and heating and electricity and biofuel productions. These are the applications. Hydrogen energy. Hydrogen energy contains the zero emission fuel. Uh, the energy method it is used for which we
Raghavendra sir, are you there in the meeting? Okay. Sir, please,
Got disconnected.
share your
Got
screen as well.
disconnected. Yeah.
Your PPT.
Yeah. Can you see my PPT now?
Yes, sir. Yes, sir.
Yeah. From just can you tell me from where I missed that? So
So you can continue it from here, sir. No issue. It was just a couple of minutes.
this Indian commitments for the hybrid system is
Yes, sir. From here you can.
So nowadays, India is committing to the utilization of renewable resources. India is heading most of renewable resources utilization. So in utilization, India is a leading country, has a fourth ranked worldwide usage of renewable energy systems. This is confirmed by the International Renewable Energy Agency, IRENA. This IRENA is highlighted that India is the fourth country using the renewable energies to generate the uh, uh, electrical power or energy resource. So India is just means within the span of 5 years, it added 65 gigawatts of renewable energies, which is a combination of both the hybrid and individual resources. So which we can with this how the India is going at with utilization of renewable energy resources using hybrid systems or individuals. So recently, India also made 5 commitments with the COP26. This COP26 is the one summit, international summit, which is working for the environmental protection and for the international. This is a so in that summit, the India is committed 5 commitments. One is the achievement of target of net zero emission by uh, 2070. So increasing the hydrogen utilization of hydrogen energy and the combination of with another solar energies, so which we can generate the net zero emission. This can be achieved by utilization of these combinations, bringing non-fuel energy capacity to installation or execution of 500 gigawatts of renewable energy systems by 2030, bringing it to economical carbon insourcing down to 45% by 2030. That means the reducing the utilization of fossil fuel utilization 45% is reducing the 45% by 2030, fulfilling 50% of Indian energy equipment through the renewable resources by 2030. So whatever the utilization of energy in our country will be run, 50% of the energy, 50% or more energy will be run using the renewable resources. By doing this, India is highlighting the focus on making the hybrid energy systems as a key energy sources. We can conclude that. So the conclusion of this session is that the hybrid renewable energy systems are very important to the world and individual country journey. So towards the clean energy, to get the clean energy. This energy shows the remarkable progress in technology, capacity, integration. With this high target and amazing policies, India is making a use of these resources to achieve a sustainability goal. There is a lot of policies involved, brought our country. We can say proudly that we brought up many policies for a utilization of renewable and hybrid renewable resources. This is a very achievement of our country for the sustainable towards the sustainable goals. With the growth of investment and regional collaboration of rural and solar and wind energies as the growth is strong, the solar and wind energies are not a convenient anymore. They are needed now. So now we can tell as the hybrid renewable energies is not convenient. Now in future they are going to be needed. Means like that how now we are using the cell phones is is our one of the regular it is a equipment. Like that in future all the hybrid renewable resources are the main resources we will consume for our general needs of energies. Hybrid energy systems has a great promises for the future, and in combination of energy storage technologies that can be greatly reduce the combination of fossil energies to cope up with the harsh climate impacts. So the hybrid renewable energy systems has a better future. But if it is combined with the storage systems, then it will again a very utilization. So this will raise the climate impacts. So whatever the climate pollutions, all this will be reduced properly. So this with this section, this is concluded. So there is some frequent asked questions. So can I go ahead with these questions?
No, sir. Right now, not required.
Okay. So any queries? Any queries from the participants?
Dear participants, if anyone happen to have any questions, you can ask the resource person. So we'll take it as new questions. So as we conclude this incredibly insightful session on hybrid renewable energy systems, it is my honor to propose the vote of thanks to our esteemed speaker, Mr. Raghavendra Reddy. On behalf of Maulana Azad National Urdu University, the organizing committee of this FDP and all the participants, I extend our deepest gratitude to you, sir, for sharing your extensive knowledge and real-world experience with us. Your session was truly enlightening, providing a comprehensive understanding of hybrid renewable energy systems and the important role in achieving sustainable and efficient energy solutions. Your practical insights drawn from over 14 years of hands-on experience in the renewable energy sector and your leadership in managing large-scale projects have inspired us all. We are thankful for your time and effort in joining us and for delivering such an engaging and thought-provoking session. Your contributions to the field and your dedication to advancing renewable energy solutions are truly commendable. Once again, thank you, Raghavendra Reddy sir, for your invaluable contributions. And we look forward to learning more from you in the future. Thank you so much, sir.
Yeah, thank you. Thank you for all the team who is giving this opportunity for me, and mainly on renewable resources. It is a very good opportunity for me. So I express my sincere gratitude to all the this members involved for giving this opportunity. Thank you, everyone, and thank you for the participants who is involved for this session. Thank you, everyone.
Thank you, sir.
Thank you,
No,
ma'am.
thank you. Welcome, sir. Thank you all participants for your patient listening. Now, please kindly fill up the feedback on attendance Google form, which will be shared in the chat, and then you can leave the meeting. And let me remind you that tomorrow's the last day's session for this faculty development program is going to start from 2 o'clock, and it is going to conclude at by 8 o'clock. So tomorrow's sessions will be starting from 2 o'clock. So kindly join the meeting from 2 o'clock onwards. We'll be having 3 sessions tomorrow, starting from 2 o'clock. The first session will be from 2 to 3:30. Second session will be from 3:30 to 5. And third session will be from 5 to 6:30. 6:30 to 7:30. For 1 hour, you'll be having 1 hour assessment, the test, which will be in the form of MCQs. And from 7:30 to 8, you'll be having the valedictory session of the faculty development program. So thank you for now. Thank you, everyone. Let us end the meeting, and tomorrow kindly join by 2 p.m.
Thank you, ma'am. Thank you for the cooperation and support. Thank you, everyone.